U equals 1. How are those skills
If you guys forgot to turn in 91 to Google Classroom, you need to do that right now to avoid late credit on it. Also, first thing on our agenda here, you will need to get out your test review, which is number 88. We've done the first two FRQs, and I'd like to start off class looking at the last one. So, find that, please.
Wait, 90 was the circuit, right?
91 was the circuit.
And then 90 was the note.
Correct. 91 was the circuit that we finished class with that you should have done for homework.
91 was the circuit. Yeah, this one was
Okay, so today we're going to do one FRQ together. The handout you picked up will be 92, and that will be some integration practice.
That's what I'm trying to.
Yes, you need to turn that in today so I can do that.
Okay.
Yep. So some practice on integrating, and specifically practice on use substitution integrating, which you should be feeling pretty good about. And then finally, turning in some of the notes from last class to give you some participation points. And then some class times to finish up the test review. After we go over this third FRQ, though, you should have the front page of the test review finished. So it would really just be the back page. Okay, I think this is the first day that there's been a tentative date for your Chapter 5 test up on the board. Still got a little bit of time there, but again, use substitution is a big one. I know it feels like we practiced that a lot. We're going to practice a little bit more today, but if you can't do use substitution, it's going to be pretty hard to pass the next test. There should be several questions of that on there. All right, this third FRQ is kind of interesting in that it is a little bit different and maybe not does not seem comparable to some of the other ones we've done. But this is a good and commonly asked type of FRQ. We just hadn't had a chance to look at it yet this year. And I'm sketching the picture up here because I will need to refer to it quite a bit. Okay, so third FRQ. It says let G equal integrating from 1 to x of f of t dt. So they give us this picture, they tell us what g of x is equal to, and then they're asking us to do 6 different parts that go along with this. Now, the best advice I can give you on this question type is you can see part A is going to ask for g of 4, g prime of 4, and g double prime of 4. So, with this type, I really feel like it makes sense to just go ahead and figure out what g prime is and what g double prime is, and have that in a nice, easy to find place, because we're probably going to refer to it a couple times during this FRQ. So, to go from g to g prime, I need to take the derivative of the left side, which means I need to take the derivative of the right side. What is the derivative of the right side? It's not f of t, but that's close. That's f of x. That's the second fundamental theorem of calculus. So that's one more time where we need that. Also, when we need the second derivative, it's like taking the derivative of this side, so take the derivative of this side. I really feel like if you do that at the top of your page, and then as it asks for things like f prime at -1, you can have at least a reference of where to go and seek out the information a little bit quicker. Okay, so part A wants us to find g of 4, g prime of 4, and g double prime of 4. Okay, so g of 4 means I should be plugging in 4 here. So when x is 4, that means this is 4. And this graph over here, this is the graph of f, not of g. That makes a big difference. So how am I supposed to integrate 1 to 4? Yeah.
Are you supposed to use trapezoidal?
Okay. Well, you're a step ahead there. It's going you have to remember that integration's area under the curve. So if x is 4, if you want g of 4, they're really just asking you to calculate the area from 1 to 4. So here, I don't know, you could do this a lot of different ways. Yes, you could do a trapezoid, or you could do a square and a triangle. You can split it up a lot of different ways, but we need to be able to get this area. This would be my picture is a little bit different. It's not exactly to scale. So this would be a triangle 1/2 base times height. So I believe this should be 3/2. Or if you did a trapezoid there, you would end up with 2.5 for the whole thing. Again, you should probably be looking at the picture on your paper because this goes exactly through that, makes it a little bit better. So 1/2 base times height, this would be a 1/2. 1/2 base times height, this would be a 1/2. Except this is below the x-axis, so negative. So as we've done in the past, if you're asked to find an integral and you don't have the function, but you've got a picture, it's the area under a curve. Split it up into any geometric shapes, squares, rectangles, triangles, circles, quarter circles, whatever you want, and then add those together. So this would be 2, 3, well actually these two just cancel each other out. So 1 plus 1.5 would be 2.5, or 5/2. Is everybody okay with what I'm doing there to come up with that number? Okay, I don't know when this was FRQ, but it looks like they did give 1 point for this. And of course you need to understand the calculus of what it's asking you to do, but the real work was just area of some basic geometric shapes. Looks like to get the second point here, we have to get both of these two correct. So g prime of 4, this is where I think that writing this at the top is going to make this a lot easier for you to figure out what to do. If you want to know g prime of 4, that's the same thing as f of 4. And what is f of 4? -1. It's the, remember this function is f, so when x is 4, y is -1. Answer was right there. So you can see how much easier that is to answer if you have this little reference, so that you can see if I need this, it's really just the same as that. If I need g double prime of 4, it's really just the same thing as f prime of 4. So what is the derivative of f at 4?
-1.
Very good. Remember, derivative is just like slope. So this nice little straight piece, you can count rise over run, -1. So once again, I hope I'm at least convincing you that on this type of question, just take the derivative of both sides, take the derivative of both sides, and then you've got a quick little reference for whatever you need in this question. It's a little bit easier to figure out. Okay, on to part B. Find the instantaneous rate of g, that would be g prime, with respect to x at x equals 1. So here's another time we can use this. If you need to know g prime of 1, it's the same thing as f of 1. Sometimes I think they give you credit, like this counts as like showing your work, so you might as well write it down. And f of 1 just means you go to function f and find the y value when x is 1. The y value when x is 1 is 4. Not difficult to get the answer, but again, you just have to know what g prime was equivalent to. So if you write this at the top, you can find that a little bit easier. Yes, Grace?
Why is g prime or double prime of 4 -1?
Because g double prime of 4 is the same thing as f prime of 4. F prime means the slope or the derivative of f. So if you count the rise over run at this time, at that instant, it's going down 1, right 1. Rise over run. The only way for you to calculate the derivative of f is to use its slope. Derivative and slope still basically mean the same thing. All right, part B was worth a point, and again, the answer is right there. You just had to know this relationship, and if you write it down before you get going, then it's a lot easier to figure out. You don't want to try to recreate the wheel every single time in these questions. All right, find the absolute min value on g on the closed interval -2 to 4. Well, as soon as I hear absolute max or min, in my head I'm thinking about extreme value theorem, which would be you should test the endpoints, -2 and 3, and any critical numbers, which in this case would be anywhere it's crossing the x-axis, which would be 3. So in this case, we don't need it twice. But anytime you need absolute max or absolute min, those are the only values that you have to if I read the, oh no, I'm sorry, I misread the question. The endpoints are -2 to 4. So there we go. So we do need the 3. So if I would like to know g of -2, go up here, g of -2, this is when x is -2, so I really just want to find the area from 1 to -2. So 1 to -2, the only way for me to do that is with the geometric shape here. It is a triangle, so 1/2 base times height, and that should be that has an area of 6, but there's something wrong about that. 6 is not what I should put down here. Let me write the question down so I don't have to flip back and forth. 1 to -2. Do you see how if you start at 1 and go to -2, you're moving to the left? And if you're going to the left, that makes the area opposite that, so -6. Or, if you'd rather, remember you can change these bounds. You could change it from -2 to 1 if you multiply it by a negative. And then you can do left or right. So either way, it's 6. Or I'm sorry, -6. -6, because you're going right to left or you're switching the rounds and making it negative. Okay, G of 4 would be asking what's the area from 1 to 4. I feel like we already did that. Sorry, this is not. This is F. Didn't we do that in part A? So we did G of 4 in part A already. So if we're paying attention there, we got 5 over 2. And then finally for 3, this is like the area from 1 to 3. And if you're writing your areas on here, like I did, it's a lot easier to keep up with what those areas are. You don't have to recreate the wheel here. I had 2.5 plus a half, so this should be 3. From 1 to 3 had a positive area of 3. You guys okay with where these numbers are coming from? Okay, so the whole point of doing all of that was trying to find absolute min. So looks like it would be -6. It's the smallest of those numbers. -6 is the absolute min. And in this question, they give you 1 point for the answer. They give 1 point if you did the endpoint analysis. So did you think to test both endpoints and show the work, or show what they were equal to? And the interior analysis. So did you check the point where it was crossing the x-axis to one other place where it might be changing? So 3 points for that. So conceptually, there's quite a bit of stuff going on there, but arithmetic-wise, it was really just finding the area under the curve. All right, D. The second derivative of G is not defined at x equals 1 and x equals 2. Okay, I'm just writing that down so I can remember. How many of these values are x coordinates of points of inflection on the graph G? Okay, so to remember what a point of inflection is, that's where the concavity is changing. A point on the graph where the concavity is changing. So for points of inflection can occur at 2 times. They can occur when the second derivative is undefined. So we would want to think about when x is 1 or x is 2, or when the second derivative is 0. So to know when the second derivative would be 0, again, I think it helps to look at this. We would be thinking about when this is 0, it would be when this is 0. This is the graph of f. F prime is his slope. Okay, so is there anywhere where the slope is 0 in this question? There's a couple places where the slope's undefined, but here, because it's a cusp, but they gave us this one, and here, that's also kind of a cusp, that sharp turn, even though it's not as sharp. So I wouldn't say that there's any others there. Okay, but for this to be a point of inflection, the concavity has to be changing. So we should see at this time, does the second derivative switch from positive to negative or negative to positive? So at x equals 1, right here, is the second derivative changing from positive to negative or negative to positive here, or neither? It is changing. It's changing from positive to negative. The second derivative is the same thing as the slope of the function. Slope was positive, slope was negative. Was concave up, then it was concave down. So at x equals 1, this changes from positive to negative. So x equals 1 is a point of inflection. Again, I can't really emphasize this enough. There's not a lot of work to be done, but you have to remember that definition of point of inflection. And if you don't have a clear, where am I getting f prime from? Where am I getting g double prime from? You don't want to have to recreate the wheel every single one of these. This is helping me out a lot. I'm trying to figure out something about this, so I know I'm looking at the slope of the graph, and that's what's making that easier for me. But at x equals 2, the slope goes from negative to negative. So the second derivative is negative, the second derivative is negative. So it's going from concave down to concave down. Concave down to concave down. Is that a point of inflection? Okay, so there is only one. So you get a point if you can figure out that there was only x equals 1 was the only point of inflection. You get a point if you show y x equals 1 was a point of inflection. And actually on this, I'm going to add a little bit of work to this. I don't know that it would be graded like this, but I want to be safe here. It's hard to refer to g double prime when the graph is really f. So this was the same thing as this. This is what I really thought about. I feel like this is a much safer justification than the top one. Again, it's the same thing. G double prime is the same thing as f prime. G double prime is the same thing as f prime. So again, I'm not really putting that much thought into that. And okay, I erased it, but then you got a point if you showed that this is not a point of inflection. So maybe saying that the second derivative went from negative, but then it stayed negative. Or the first derivative was negative, and then it stayed negative. So something like that could get you the third point. Explaining why you didn't think x equals 2 was a point of inflection. Again, that one's kind of tough. I had to put some thought into that one. The best hint that I can give you guys, I'm going to try to wear you out on this. The best hint I can give you is writing these down from the beginning. Write the statement given to you, take the derivative of both sides, take the derivative of both sides. This has been my guide through practically every single part of this. Okay, part E. For what range of the values is the graph of g increasing, decreasing, concave up, and concave down? Okay, well, that's a lot. So g increasing, decreasing, concave up, concave down. Okay, so g is this guy. He essentially means the area from 1 to whatever x value. So if you look at your picture, is the area increasing or decreasing from 1 to 3? It's increasing. That area is above the x-axis. If the area of f is increasing, then G is increasing, because that's how they're defined. G is the area under the curve from 1 to x. Okay, what about 3 to 4? Is the area increasing or decreasing? Okay, how do you know it's decreasing? Because it's under the x-axis, so it's subtracting from that. Okay? This one's a little trickier. I want you to think about this one before anyone says it. The rest of the graph was 1 to negative 2. Look at your picture and think about if x is negative 2, what you think it should be. So from negative 2 to 1, positive or increasing? Or, sorry, I gave it away there. It is increasing. So if we include that with this, they have that as negative 2 to 3. They got the same decreasing. Okay, for concave up and concave down, I know that I would want to be thinking about the second derivative of g, whether the second derivative is positive or negative, and what the second derivative of g represents is the same as the slope of the graph. So when the slope of the graph is positive, negative 2 to 1, f prime is positive, and f prime is the same thing as g double prime. I have that written on the top of the page. That's how I know that so quickly. G double prime is going to be negative when f prime is negative, and f prime is the slope of f. So anywhere that the slope is negative, like 1 to 4. Again, those things would be very difficult to do if I'm trying to think about g double prime has to be positive to be concave up, but what does g double prime have to do with f? That little box we made at the top made it a lot easier for me to know what I need to be looking at on the graph. I think this part's, yeah, E and F are just made up. I think A, B, and C, no, I'm sorry, A, B, C, and D were real parts of a real FRQ. E and F were added on to by some other teacher. So, okay, last part, write the equation of the tangent line of G at x equals 2. Equation of tangent line. So how did we do that last semester? Tangent line is always linear. How do we write the equation of a linear line? One more time. Okay, you could do y equals mx plus b. I would much prefer you to use point slope though. It's a little more versatile. This is going to require you to know the y-intercept, which is a whole nother problem. But they said when x equals 2, so you've already got one of the three numbers you need to plug in. Okay, so this is supposed to be for g. So g of 2, if I'm looking at the top of my page, is the same thing as integrating 1 to 2 of f of t. So this is like the area from 1 to 2, which, again, I already have that done. Area from 1 to 2 would be 3. Sorry? Did I miscount that? Is it 1.5? I know we did that earlier. Yeah, it's right here. You're right, 5 halves. I'm not seeing that yet, though.
I think you looked at 1 to 3.
Oh, I went 1 to 3. Okay, yeah. Thank you. This is why I don't like to copy down my pictures. I really probably should have used a real one here. So from 1 to 2, this would be 2.5. Sorry, it was 2.5. So when g is 2, for an x value, it would be equal to 5 over 2. And then finally, this would be the slope at 2. So slope in calculus is derivative. Once again, if you're looking at the top of your page, g prime is the same thing as f. Writing that on our top makes us only think about it once. And f of 2 is just the point of the graph. When x is 2, y was 1. So what I need you to get out of this one, the most important thing, is I hope that I've convinced you that this helps as a reference, because you need to think about these things a lot, and having that to peek at helps. But I will try to find another 1 or 2 of those for us to practice before the test, because those are good question types. But you guys have something that jumps out at you, though, that you want me to clear up real quick about that? Okay, before we move on, I'd like to ask, of those parts, A through F, what would you consider to be the easiest to do? A? A or B, probably. And the most difficult, I'm guessing D or E? Yeah. So you might want to look back at one parts of those, but again, I will try to provide you some more practice, because you will feel much better about that after you see it a few times. But when you see that in the future, please start off with this. If you don't use it, then fine, but I do think that's the way to go. Okay, next up, I would like you guys to get some more integration practice from today's handout, 92. There's a handful of those questions that should integrate very nicely where u substitution is not needed at all. And then there's a handful of them where you should be doing u substitution. So if you need more practice with u substitution, this is an opportunity to get it. And if you've got u substitution down, then it should be significantly easier for you, I guess. But those 20 questions is what I'd like you to look at next. And I will specify that I will ask that you please try to work them in order. Try question 1 before you try question 2. Try question 2 before you try question 3. Try question 3 before you try question 4. That way, as you guys have questions, everybody should have probably looked at the same question that you're on, and you're not jumping around and haven't tried it yet. So that way I can help without spoiling any of that. But finish that up first. Turn in the notes from last class so I can give you a few participation points, and then you can spend the rest of class / homework on finishing up the back page of that test review. Okay. And for today, I'll try to do most of our help here on the board, since whatever questions you may have, other people probably have similar questions. So 5 or 10 minutes from now, I will take questions on the first couple. Also, you're welcome to do your work on the back page of this, since there's nothing back there. Some of these questions, like I hope question 1 you don't feel like you need a lot of space for, but some of these questions are going to need more space than it shows. So at some point you're either going to want another sheet of paper or to copy it onto the back of the page so you can just do it on the back. But I will of course need to see your work. for the points on it. So. I guess I should also add, if you feel like you are pretty good at U substitution, you should be trying to use this practice as an opportunity to work on your speed. So obviously the quicker you can do the process and get the correct answer on the test and on your AP exam, that just means that you are buying yourself more time to work on other things that may not be as good for you or not as easy for you. All right, offering to help out by working out questions 1, 2, or 3. Any of those that I could help with. Should have only done use substitution on one of those 3. Okay, I'll give you another 5 or 10 minutes and ask about the next few.
You said you should have only done your substitution on one of them?
Mhm.
Which one?
Well, you don't need it on number 1.
So,
You can just undo the power rule on number 1.
I thought you did need it because the function is in parentheses, so I thought that meant that.
Wait, why do you use that?
Here, the function is this way, so.
It's the same thing.
Why?
Here
Oh,
you're
it's just
integrating
for-
all of this to get to
Wait,
the
no.
Here you're integrating all of this to get to There's no new substitution for 1. Just undo the power rule 3 times and put your plus C. I mean, you can also think of it like this, if the parentheses bug you. Like, if you have something and it's in parentheses, it's an understood 1. So you could distribute that and remove the parentheses if you think the parentheses are changing something. Number 3.
Did you do this?
Okay, so for question 3, since there's nothing written here, that means it's going to be an understood what? Okay. What can you take the derivative of to get 1? Y and plus C. That's it. Again, some of these shouldn't be too challenging, but it's good that we can clear those up. But some of these you will need use substitution for. Bless you. Bless you.
Thank you.
For one other option, for those of you that feel pretty good about this skill, I did just put up the solutions on the website, and those solutions do have some steps. So if you can work quicker than I'm taking questions on the board, then you're welcome to use that to help guide you. The only catch to that is if you're way ahead and you ask a question way in advance, I'm probably not ready to answer that yet. I don't want to answer it until everyone's tried it. been another 7 minutes, so I will take any questions 1 through 7. Anything 1 through 7 I can help with? Besides question 3, because we already talked about that one. Yeah. Number 4? Sure. Okay, so what I noticed about 4 is that this x minus 3, if I think about this, if I try to put x minus 3 in my answer, this isn't going to create any chain rule to that. So because of that, I don't have to do u substitution. We can simply just undo the power rule. So raise the power by 1, divide by the new power. And again, because there's no chain rule, that's what makes it not be complicated enough to need the u substitution. Add the plus c because there could be a constant there. And just a reminder, you guys don't need to do this every question, but I think it would be a mistake not to test a couple just by taking the derivative. If I take the derivative of this, I would bring the power down, lower the power by 1, take the derivative of this, and then notice how this goes back to this, so that all but confirms that's correct. So, again, maybe one of the things y'all need to get out of this is trying to differentiate when you need u substitution, when you don't. Okay, anything else about number 4? Okay, I heard one more question. Somebody else had 1 through 7 question?
6.
Okay, so question 6, what I would do is try to rewrite this first. So as we know, the constant stuff can come out front. So I'm just going to pull the 4/3 out front and deal with that later. And instead of saying the square root of y, I could say y to the 1/2. And instead of y to the 1/2 being in the denominator, I can move it up to the numerator and make it negative 1/2. And if you do all of that rewriting, now we just need to undo power rule. We don't even need to use substitution on this one. Raise the power by 1. Divide by the new power. Dividing by 1/2 is the same as multiplying by 2. So in the end, I came up with 8/3 square root of y plus c. Always in your interest to try to rewrite it before you do the antiderivative. Okay, I'll give you another 5 to 10 minutes, and then I will take a few more questions a little bit past where you should be now, which should be around question 7 or 8.
guess I'm thinking about. Either 7 Starbucks or probably 7 Starbucks. And I get extra charges. Because 14 is 1 over 9x. No, I didn't finish it. Is this not too much?
Yeah.
Yeah.
I knew it was wrong.
Real good question, right?
Yeah, I know.
All right, it's been almost 7 more minutes, so any of the first 10 questions that I can help with. Questions 1 through 10.
9.
Number 9. Sorry, my T's look like plus signs, but... Well, the good thing about 9 is you don't need to do U substitution on this question. You could rewrite this one with exponent rules and rewrite this term with exponent rules. And then we can just undo the power rule twice. So here, raise the power by 1, divide by the new power. Here, raise the power by 1, divide by the new power. It could be a constant that we can't see. And for simplicity, typically we don't leave negative exponents in our answer, so I would move this back to the denominator, move this back to the denominator, and I would end up with that. So rewrite each term with exponent rules and then undo the power rule. U substitution would not be helpful on that one. Okay, one more for 1 through 10. Okay, I will reset our timer and ask again in a couple minutes. What? Yeah, give me 1 second. I have that, I don't know why, but I skipped that one, so I don't have that one done yet. And those solutions are not mine, so. Like that. Sorry, the solutions cut off the bottom of the number 8, so. So there's the answer to 8, since you can't see it. It got cut off on the website. I can work that one out if y'all need to, but timer's got a few more minutes.
Like 1 minus X. And then it might be easier so. In the beginning, like this index or whatever, I just took X out of this parentheses.
If I don't write U equal to what, and just write like this, can I get point and free response?
It depends on the free response. Sometimes one of the points is you just saying U is this. So I can't, it just depends. Sometimes they give a point for that, sometimes they don't give a point for that. To be safe, you should always write what it is.
It takes it out.
Okay, it's been 8 more minutes, so I will take any questions 1 through 14. Anything 1 through 14 that you're finding to be harder than the rest. Number 11. Okay, 11 is a great one to ask because I suspect you probably started off trying to pick out a U, and if you guess something like this to be U, again, there's nothing wrong with picking the incorrect U, but after a second, you start looking at this and it's never going to fit that. So, I don't know if I need to use U substitution on this question, but you really need to rewrite this a little bit first. So, let's go ahead and distribute this. Multiplying things with the same base, we should add the exponents. Multiplying things with the same base, we should add the exponents.
And this is minus.
You okay with where those came from?
Yeah.
Okay, and now I can see that there's no chain rule part in this, so I can just undo power rule. Raise the power by 1, divide by the new power. Dividing by 5/2 is the same as multiplying by 2/5. Raise the power by 1, divide by the new power, and don't forget the constant that could be there. And that should be it.
Wouldn't the 2 be multiplied out to the x to 5/2 as well?
It was. So when I raised this power by 1, that became 5/2.
Can we just write that as the same?
Dividing by 5/2 is the same as multiplying by 2/5. And I just said 2/5 times 2 was 4/5.
But wouldn't the 2 be multiplied to the x to 5/2 as well as the x to 3/2?
Oh, yes, you're right. I'm sorry. So when I distributed this, I should have distributed this 2 also, which should make this a 4. You're right.
What's your time?
I'm on this one. Anything else about 11 you want to ask? What's your question?
Could you, like, take an x out of the parentheses and solve it that way? And then u would be 1 minus x.
You could factor out an x at the start if you wanted to. I don't know that u substitution would work after that. You'd have to just try it. But technically, I mean, if both of these have an x, you're welcome to factor the x out.
I got an answer.
Did you get this answer?
Well, I got negative x times.
Okay, hold on. Let me
Okay.
start it off the way you said, and then we can see where we differ. So you thought to take out a GCF here. So if I pull out an x, x to the 1/2 times x would be x to the 3/2. Like that. Okay. Now, personally, I think you should still distribute this, which is the way I first worked it. If you think that this is your u, once you solve for du, this is never going to be 2x to the 3/2. So u substitution is not going to work there. So you can pull out the x like you want if you want to, but you're still going to need to distribute this and work it the way I did.
Okay, my problem was I treated one like an x.
Oh, okay.
So yeah.
Again, the best advice I can give you guys, if you have any doubt about your answer being correct, try to take the derivative of your answer. If it looks like that's going to work out, then you're probably fine. And if it looks like its derivative would be nothing like what you started with, you might have taken a wrong turn somewhere. Okay, I don't remember the number that I set up to, but I'll give one more chance before I reset the timer. Anything 1 through 14.
Can we go to 13?
13? Once again, sorry, my T's look like plus signs, so. Okay, so I'm going to try to rewrite this. So I'm going to split apart my fraction here. I could put t over the square root of t, as long as I put 2t squared over the square root of t. So sometimes splitting apart your fraction is a good start. This can be simplified because dividing things with the same base, the base would be t here, is like subtracting exponents. 1 minus a half would be a half. Same thing over here. Dividing things with the same base, you should be subtracting the exponents. 2 minus a half would be 1 1/2. And now that I've split up this fraction and simplified each of those, I think we can just undo power rule. Raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. And in the end, you still need a plus c. I'll leave that one up on the board. Okay, I'm going to set one more timer and take questions one more time today while you guys are here. Again, the website has solutions with steps, so you can use that outside of class. I've also been trying to record all of these that you're asking to put on the website, so you're welcome to revisit those if that will help.
So it'd be negative x. Did you do this up for 15? Would it be 3 to the negative 1? No, it's like, what do you make it? So 1/3 negative x to the negative 1 plus c.
Yeah. X in front of me. Oh yeah, it's one, once it's integrated, we got into X.
I should do 60. Don't tell my dad.
I haven't checked the other one, so I don't know if you did that one. This time it depends if it is.
Okay, sorry.
That's fine. I would put up that fraction into 3 different variants. But if you rather do one, this one could, I think it's harder.
Yeah.
On Google Classroom, assignment 90, you turned in 92 at so that's not even until the next class, but just so you know, I don't have 92. 90 was the notes we did together last class.
Let's see. I was looking at the review.
Yes, sir.
For the first 6 questions on the back,
Mhm.
would just the equation be an acceptable answer? Or do you have to find the exact?
You need to find the area.
Yeah.
So this one, you should be integrating this function
Yeah.
from this x value to this x value. So integrate from -2 to 4 x cubed.
Okay, I see what you mean.
Because remember, integration tells you how much area there is under a curve. So you're not always going to be presented to, it's not always going to look like that. Sometimes you need to know that if it's talking about area, you can write it as integration and do it. Okay, it's been 11 minutes, so as I promised, one more time, I will take a couple more questions on the board. Anything else you've tried on this handout that would be beneficial for me to go over with you? Okay. Well, with our new bell schedule, you guys still have 15 minutes. So if you're not finished with that, you should keep on going. And you should be trying to get some of the back page of your test review done. We did the whole front page together, but you guys need to practice the back to see what you are able to do and what you're going to need help on. This is a B week, so I will not see you again until Monday. So you've got lots of calendar time to finish that up. But I do need you to try to finish that, please.
Oh, is it the Arkansas school?
Yeah.
Arts.
Yeah.
Where's the multiply by this? What's the track? You guys all cook, right?
1 year and a half.
Middle school. That's what I did. Yeah, it's -3. Because with like 2x squared, you get 4x. So you multiply by the original before you take it. It would be 3.